My name is Yuri, and that's what I'm going to tell you. Had I been asked what is the coolest technology in AI over the past 10 years, I would say it's something that we taught the computer to understand things. The phone would understand if its owner took it in his hands or another person. The phone identifies the direction of your eyesight and then does something. The computer will recognize your speech. And we at our company do document understanding. It's far beyond computer statistics. Computer does really start to understand us. How have we arrived here? The computer understanding is based on what's called distributed distributions, otherwise called embeddings. There are two types of embeddings: dense ones that are used in computer technology and sparse ones. The sparse ones appear more often when we try to reproduce the mechanisms of a human brain. So these two types are more or less equivalent and do the same thing, retain understanding in digital form. 10 years ago, we tried to solve the target problems straight on, but the quality of the solution was not very high. And then we started to teach the computer about everything that exists in the world. So the modern approach to solve computer tasks can be explained like this: a big brain delves into large data sets that exists in the subject area and tries to predict other data items among the data items they're dealing with. You can learn on different problems on everything that there is. Then, based on the derived rules, we teach them to act for specific problems. The understanding derived this way allows solving very sophisticated problems, like, for instance, to play Go, do machine translation, and everybody knows that. The complexity of problems can be measured by the number of rules that you need to solve it successfully. For simple tasks, we had statistical algorithms, and they were doing well. For a complicated task, this approach stops being efficient and effective, because many rules can only be derived when you have the understanding of the subject area. So this way, the computer arrives at concepts of the subject area that in the past could only be done by experts and specialists. Humans can set up models of tens of thousands of rules, whereas the computer can deal with billions of rules and identify the build itself, the models of the subject area. So this is how we built the artificial brains. Actually, the rules indeed resemble the ones that humans use. In case of images, the computer builds an internal image language, including textures and features. Can this kind of brain solve all kinds of problems? Generally, we expect that in the future we'll be able to do that. But there are technical hurdles. Firstly, we have a choice between quality or speed. Modern computer systems are 3 orders of magnitude lower than a human brain in terms of speed of calculation, and by 5 orders of magnitude in terms of energy efficiency. So in order to embed computer vision in a phone, we can use only 1 in 1,000 of all the rules and lose some quality. In terms of text, computational models are much larger, and we have a choice, even at the learning phase, either to teach the model less in a week, or more in a year. It's good if we have a supercomputer that allows to reduce this time, but then you would want to teach super large models. The largest understanding models are being taught for a month in thousands of specialized computers on parallel. Another problem is that the understanding problem requires a lot of data, and quite often data collection is restricted with rules and constraints. But the human brain is not only about understanding; it's also about making complex actions based on this understanding. And quite often we lack specialized data sets. For instance, we still don't know if the computer can be taught to think. Why? Because we don't have a lot of data to teach thinking. That's why when you attempt to reproduce thinking on a computer, we have to invent something, take some irrelevant or poorly relevant parts of data, or to do something else. Same thing happens when we teach a computer to make some manipulations with objects or to perform some other complex actions. We need to have a lot of actions in the target area, and it may take weeks, months, or even years to collect the material to teach the computer doing this. So one can state that the technologies have gone far ahead, and basically it's already come into industry. Now it's the right time to combine technologies in the right way to achieve artificial intelligence. And this race has already started. Thank you for your attention. Yuri, I'm connecting to your presentation. Thank you very much. Unfortunately, you wrapped up very fast. I think you still have a lot to talk about. Well, we don't yet have questions in the chat, so I'll ask a question. Let's start from the very beginning. How many years have you been attempting to create an artificial intelligence? Well, one way or the other. I've been doing it for about 15 years. But this said, I'm not only trying to solve the problem as a whole, but I'm also dealing with specific tasks in this area: speech recognition, text understanding, and similar things. Let's then try and perhaps figure out the evolution, what happened over these 15 years. If you compare your artificial brain with a kid that gets born, a baby that gets born, they're learning. So the AI that you're working with, how old is it in human terms? What can it do? And what is still there to be done? Well, for some problems, the AI is already better than an adult human. With other tasks, it is still like a 6 to 10-year-old kid. It's already passing some school tests. Well, you mentioned several times that when the artificial brain will fit into a phone, it will be a dramatic change. Can we talk about that in a bit more detail? We all know what a modern phone is and what are its prospects in terms of human brain being embedded. I believe that the problems that could be solved with software, well, here we have basically achieved whatever could be achieved, and all the future enhancements can only be related to the improvements in hardware. There are many phones now that include specialized chips to accelerate AI functions. And this way, perhaps you can accelerate the solution of certain problems on the phone maybe 10 times, so that the phone would approach a usual computer. And in the computer, of course, you could also speed it up 10 times, tenfold. Also, you can think of what can happen in the future. In the future, well, we are cautious. We are cautiously waiting for memristas or similar technologies that could remove the bottleneck between the memory and the CPU, and again, maybe accelerate computations by the factor of 10 or even 100 on a phone. So I think we'll be able to improve the power by the factor of 100, by 100, I mean, of neural networks on the phone. And then we could address the entire gamut of problems. It sounds quite fantastic, even though what we see now shows that what seemed science fiction 3 years ago is now becoming reality. There will be a lot of discussion about 5G that's coming, right? Well, on the one hand, large networks allow, put it this way, there are two options. Option one, we solve the problem on the phone or on the local computer. The second option is that we get the problem solved in the cloud. And modern high-performance networks with high throughput and capacity will help the phone's little brain to receive assistance from the cloud-based large brain in those cases where it's needed. And this way, we will indeed be able, maybe in 10 years' time, to get a super intelligent computer assistant on every phone. Well, thank you very much, Yuri. Thank you very much, Yuri. So I think that in a year, when we are going to meet again at AI Journey 2021, you're going to say that it's not going to take 10 years, but maybe 2 or 3 years, so that we'll be able to address the problems that you mentioned.